Good afternoon, everybody. Thank you for joining us today. Sorry about the confusion with our previous webinars. We had to take a little break with some scheduling conflicts, but we are back today and continuing with a presentation from Kimberly Grove, member of the UN Mid-Atlantic Regional Advisory Committee. Please be sure to tune in next week when we learn more about Colorado's Front Range water challenges with the presentation from Denver Water's Manager of Demand Planning, Greg Fisher. As a quick reminder, we are recording each of these webinars and posting them to our YouTube channel. A link will be disseminated as soon as it's available. And all participants have entered this webinar muted, so please enter your questions in the chat queue. And barring any technical difficulties, I'll try to turn on your mic at the end of the presentation to facilitate a fruitful discussion with Kimberly. And with that, I am excited to introduce our presenter for today. Kimberly Grove is a professional engineer whose 20-plus years of experience has spanned the spectrum of civil engineering, including stormwater management, environmental remediation, geotechnical engineering, and construction management. A graduate of the Florida Institute of Technology, Ms. Grove spent most of her career as a private engineering consultant working throughout the Southeast and Mid-Atlantic states until she joined Baltimore City Department of Public Works in December of 2010. Ms. Grove now serves as the chief for the Office of Compliance and Laboratories for DPW. This office was responsible for developing the MS4 and TMDL watershed implementation plan and the trash TMDL implementation plan for the city. Ms. Grove has served as the city's liaison with MDE for the MS4 permit since 2010 and was integral to the implementation of the city's stormwater fee in 2013. And with that, I know we can hear Kimberly well, so I'm going to let her take it away.
Okay. Thank you and good afternoon. I appreciate everyone attending this webinar. This is on the Controlling the Uncontrollable, Baltimore City's Approach to Integrated Water Management. I am Kimberly Grove, and I am the Chief of the Office of Compliance and Laboratories with the Department of Public Works in the City of Baltimore. I want to cast your attention to the photo that I have here on this cover sheet. This is the result of tidal flooding that happened right after Hurricane Isabel in 2003, and that is our downtown area. These waters came up enough so that the roadways were not usable and the first floors of many of the buildings were not accessible. So for those of you who are not familiar with the city of Baltimore, we are on the east coast of the United States within the Chesapeake Bay watershed. The map on the left is the drainage area of the Chesapeake Bay watershed, and the map on the right is Baltimore City. It's about 81 square miles, and it is right there on the Patapsco River. What you can really see off the map to the right is that there are many, many interstates that come through it. Baltimore is a major port along the east coast, and it's one of the deepest ports. So even though ships may have to come through this peninsula here, it is still a widely used port. And because it's a port, we also have major number of railways that come through there. So the previous slide had said that we are built on the water, and we have been successful in managing our water. This slide is just talking a lot about what our assets are for both drinking water, wastewater, and stormwater. Baltimore City has a separated sewage system. That means all of the wastewater is collected in a different pipe network from stormwater. And this is a little bit different for a lot of cities on the East Coast that are the same age as Baltimore City. Many of the other cities like Philadelphia, New York City, Washington, D.C., they have a combined sewer system. We are fully separated. In addition to our very vast number of pipes, we also are responsible for the management of our drinking water resources. So the Department of Public Works is within the city government. The city itself is an independent city. We are not part of any county. The Department of Public Works reports up to the mayor, and we are a local government structure, but we act like a local utility because we provide services to the surrounding counties. That's why you'll notice in the drinking water, we're not only responsible for managing the pipes that are in the city, but also in the county. So the bottom part of the slide is just a little bit more about some of the other assets in addition to the pipes. We have reservoirs, we have filtration plants, and several pump stations. So talking about the drinking water, our reservoirs are located north of the city, and we have Pretty Boy Reservoir, Lock Raven Reservoir, and Liberty. They're located up into the counties, and the drainage areas you can see there. Each of those drainage areas have some type of regulation related to pollutants. They've been listed as impaired, so they'll have a TMDL, which is a total maximum daily load that's been assigned, meaning that there's a waste load allocation assigned to those reservoirs. And the TMDLs have primarily been related to nutrients and sediment. That is just a way so that environmental regulations can help control those pollutants, which in turn can help reduce what we need to do for treatment to bring it into compliance with the Safe Drinking Water Act. In addition to that, by controlling the nutrients, we can also reduce the potential of any algae blooms that could also create a large problem with contaminating the water source. So we have these 3 surface water reservoirs. In addition to that, the city also has access to the Susquehanna with the ability to draw water from Conewagon Dam. Also on this slide, a little bit of the history of our water management related to drinking water, and you'll see that it is going back over 150 years from when the first time that we were able to create a municipal water supply to gaining access to those reservoirs and eventually the river. And then once we started to do the water filtration plant in 1915, and then eventually in 1979, creating a water utility, which was the ability to bill customers and manage the funds that were coming in. Right now, the majority of our water that is supplied for drinking water does come from these 3 reservoirs. We're very proud of the quality of the water that comes in there. In fact, Baltimore City was just voted best tasting water in a blind taste test at the local AWWA meeting this past spring. So it's good quality water. When we have had to rely on the Susquehanna, it's been in the past during times of drought. So if our water resources are low, the water coming from the Susquehanna is also a little bit low, meaning that it may be a little bit higher in turbidity, and that can affect both the taste and what we need to do for treatment. So looking into the future and what we're doing with managing those resources is to look at what we may want to do in blending those waters and not waiting until we are in a drought condition, maybe saving some of that better quality that's up in the reservoir for when we go into a drought condition. In addition to what we already have with the water filtration plants, we are also looking at the potential of a 4th water filtration plant known as Fullerton, which is still being evaluated. For our wastewater collection system, just like in the drinking water, our service area extends out into the county. We have 2 wastewater treatment plants, both located right on the water's edge. So we are rather mindful of sea level rise and inundation from tidal surges. The 2 wastewater treatment plants are 2 of the largest in the state. And just like on the drinking water side, the management of the wastewater has been going on for over 100 years in the city. A major part of the collection system was constructed in the early 1900s, and the bulk of that system was finished in the 1950s. So a lot of the pipe material that was used is already getting past its projected life cycle. Just like the water utility, the wastewater utility was created in 1979, and in 2002, Baltimore City was one of the first separated systems to get a consent decree related to sanitary sewer overflows. Those sanitary sewer overflows were a result of wet weather conditions when inflow and infiltration into the pipes became too much, and it results in an overflow from the system, causing a potential risk to public health and safety. Then on the stormwater side, we as the city are only responsible for the stormwater system that is within the city boundaries. However, we share watersheds with our surrounding counties. And it gets a little bit strange because then our regulations in the form of an MS4 permit, MS4 standing for Municipal Separate Storm Sewer System, the MS4 permits are set up by geopolitical boundaries, but the watersheds don't work that way. So we have to do a lot of our planning in concert with our surrounding counties to make sure that we're going to get to an ultimate goal of water improvement. The first MS4 permit was in the mid-90s, and then around 2008, and then going into 2010, we were looking at the Chesapeake Bay TMDL as a part of the presidential executive order. And this TMDL was really focused on nutrients and sediment to improve the quality of water in the Chesapeake Bay. Why I point out 2010 is 2010 was the year that the state of Maryland put out their phase 2 TMDL implementation plan, and that impacted the MS4 permit significantly. The regulations ramped up very much for regulated stormwater. And then in 2013, the city created a stormwater utility. I want to point out, previous ones, you have 1979, water and wastewater having a utility, and stormwater funding was not created through a fee until 2013. So in addition to the Chesapeake Bay TMDL, the City of Baltimore also has several local TMDLs related to nutrients and sediment. We have them also for bacteria, for trash, PCBs, and chlordane. And it's very, to point this out, nutrients and sediment and the way the best management practices that may be used to address those tend to also have some type of volume control, some type of practice that will either reduce runoff or at least retain it enough for treatment so it will reduce the peak of the runoff. When you're looking at bacteria and trash, those best management practices will not be the same. And specifically, trash is a much more of a human behavior type of pollutant than, say, nutrients would be. So PCBs, chlordane are very similar in the way that they're not going to act like the way and they won't be treated like nutrients and sediment. So as we're trying to meet any of the mandates related to the local TMDLs, only a few of them will use the same type of practices to improve water quality. So we have a lot of challenges, and this is true for local utilities in any type of municipality. Trying to provide daily service to 1.8 million customers feels like you are constantly rolling that stone up a hill. But to make matters worse, we have politics, climate, which I always think that Mother Nature has a bit of a sense of humor, hence the banana peel. Regulations will sometimes feel like they are helping us with that rock, but sometimes it feels like it gets thrown at us. And affordability is the greatest challenge that you can't quite see how to overcome. For the purposes of today's presentation, I'm going to talk about 3 of the challenges and avoid talking about politics altogether. The one thing I will, though, tell you is that whether it's on a local, state, or federal level, you need to be mindful of what the motivations are for politics and how that may impact your policies and your practice decisions. So we have a lot of extreme weather events that we have to endure here in the city. I was talking earlier about, well, at least we don't have volcanoes yet, But when it comes to temperature, the heat waves are an easy one to think through because the water usage may go up. Irrigation, just the same as when you're in a drought, the irrigation usage may go up and put a demand on your drinking water resources. But I want to point out that the extreme freezes or the quick freeze and thaws can wreak havoc on water distribution pipes. In this past winter, we endured something that was rather unprecedented. It wasn't just an issue of frozen pipes and frozen service, which we've had in the past, but also a lot of when we've had extreme freezes, but also a lot of water main breaks. And they coupled together almost in a 6-week perfect storm where we saw the number of reported water main breaks and frozen services and customer service requests that are monitored by 311. The reports within a 2-month period were as much as what we would expect for most of the year. So that put not only a large demand on our operations with a lot of people going into overtime, but also the available materials and contracted services that we were needing to address this. And keep in mind that weather never really stays localized in our little 81 square mile city. Our other local utilities were having the same type of events happening with them and the same type of impacts on their drinking water pipes. So it was a very, very tough winter, and that we're starting to see this more and more often in the last 5 years. I'll talk a little bit more about floods, but I do want to talk, while I'm still on this slide, about wind. Wind doesn't always seem to have a direct impact on water, but it does have a direct impact on providing electricity and power. And so we are very mindful of the impacts of some of these events. In fact, the derecho that we had in 2011 had knocked out power for many of our customers for up to 2 weeks. And that was tough. But what was even tougher was then to kind of turn around and try to talk to the communities about the need of putting in more trees and installing more trees. Folks don't want to hear about trees when a tree knocked down their power line for 2 weeks. So we're mindful and we keep they're cognizant of the impacts that wind events can have. So let's talk about floods. The city does have a flood alert system. Those are all the gauges that are shown here on the map. In our system, it's an online real-time system. We're also able to tie in to USGS gauges and also gauges that are maintained by NOAA. The systems include both stream level gauges as well as rain gauges. And over the years that we've had this, we've started to notice a variation even within the confines of the city of what a typical rainstorm can look like. You can have a 1/2 inch over at this location and 2 inches up here. So we're very, it's a good thing to have so many gauges and to see that variation rather than just depending on the one national gauge that may be down there, to give an idea of what the rainstorms and how the cells may be acting during a short period. So these are some of the typical effects of storm events, and this is not just for Baltimore City. I'm sure everyone has something similar. I think I saw some for the ones for Miami earlier. So it affects, obviously, a lot of our transportation. The middle picture here is our I-83, which is the Jones Falls Expressway, and when you reduce the amount of lanes that can be used, expressway no longer has any meaning. But what we also see is the potential for flooding over bridges. And sometimes this photo here on the right, this is a drift catcher. So one of our major streams is the Jones Falls. And for a large portion of the city, it is open. It's an open channel. And then it comes into the tunnel as you get into the downtown area. This drift catcher, which is nothing but a large set of concrete columns, is set upstream of the tunnel so that you can catch most of the large driftwood instead of it going into the tunnels where it would be harder to displace and unclog. You look real close right here, and to give you a sense of scale, this is a large dumpster. This dumpster happened to flow into the Jones Falls during a July storm, a major storm, and it, along with all of this debris, came up along the drift catcher and then starts to create a dam, which then builds up ahead. And we have been mindful and conscious of how to try and clean up this drift catcher on a regular basis, because if not, we've experienced as much of a 6-head difference in the Jones Falls just because of this damming effect. Unfortunately, when they built the drift catcher, they did not think about how to come in and maintain it very easily. So it requires a large crane to access this location, and it can cost anywhere from $150,000 to $200,000 each time we need to remove the debris. And then finally, this photo down here, although a little bit hazy, this is a residential unit that had to be evacuated during a 3-inch storm in 2011. And while we have had some evacuations, this was one of the largest ones. We had to evacuate 23 people, but more importantly, this was out of a public housing unit. So talking about the storm, sometimes when we're looking at models and what we need to do, we will use that standard design storm of a 24-hour storm. And if you look at some of the storms or storm events in the last 3 years that we've had, that at the end of the 24 hours, they've only resulted in maybe 1.5 to 2 inches. And looking at it, it may only be a 1 to 2 year storm. But when you take a closer look and you see how the storm is behaving within the first 30 minutes, you'll see that it is actually more intense than even a 100-year storm. And this particular one, this one right here, it was on July 30th, 2016. If that date seems remarkable to anyone, it was the date that a neighboring community of ours in Ellicott City made national news because they received 6 inches of rain in 2 hours. That's that same storm. We were fortunate enough to only end up having 2.5 inches, but you could see that same intensity was there in the first 30 minutes. And when we look at roadway flooding, it's that intensity in the first 30 minutes that can make a significant difference related to public safety. Eventually, we don't always have the typical storm response. Sometimes we have even larger responses. Both of these failures occurred shortly after some rain event. The one up here at the top left, this was a large sinkhole when a 10-foot pipe had collapsed. The 10-foot storm drain pipe is about 40 feet below ground. It was 100 years old, brick material. The collapse had at first been seen, and it had been a small sinkhole that had gone all the way down. We were able to stabilize it and backfill it enough until we were able to make a permanent, until we were able to get the materials mobilized to make a permanent fix. Then came a certain storm, a summer storm. It wasn't that remarkable. It was about 2.5 inches in 24 hours. But it carried enough energy so that all that water coming down that 10-foot tunnel pushed out any of the debris that was in and then carried everything with it. And so this large collapse from a 4-lane road happened within 2 hours. And then down here also made national news. This was the collapse of the 26th Street wall. This is a large railroad right here. And folks probably remember seeing this. This was in 2014 because the wall collapsed and then it took the row of parked cars. And I have to point out as well, it also took out 4 trees, street trees with it. But what had happened, it wasn't because any of the existing pipes had burst or anything like that. What probably had happened was the pore water pressure built up, and it was that difference between failing infrastructure and bringing it to failure. So in 2013, almost as timely for this, the Baltimore City Department of Planning, specifically the Office of Sustainability, created the Disaster Preparedness Planning Project. And because that sounds like a mouthful, we just refer to it as DP3. Earlier, that same office had created a climate action plan that was a little bit of a generic goal setting, thinking through mitigation. Now we had DP3, which was the first of its kind because it matched adaptation with hazard mitigation, and it focused on all of these areas here in the middle. Plan was developed similar to what you've seen in other hazard mitigation plans. You identify where the hazards are, you do a risk assessment looking at those vulnerabilities and impacts, and then you develop a plan. This plan though, was no small plan. It had over 50 strategies, and then those strategies were broken down into 237 actions. In the development of this plan, several agencies that would then be assigned as the lead agency participated in developing the plan, in addition to community members. And this was a very grassroots type of plan development. And in the end, the Department of Public Works had the pleasure of being assigned 49 of those 237 actions in that plan. There were a lot of lofty goals, but I do want to point out the bottom point of this bullet point is to become a community rating system classified community. And we were able to achieve that by having both that plan and then also where we were going with those strategies and commitments of the agencies to meet those goals. Currently, the city is, excuse me one minute. Currently, the city is in the process of updating our DP3. So if anyone is interested, you can see the results will be online this summer. So in addition to that DP3, DPW also had a lot of plans that were related to both asset management as well as regulatory compliance. The green box here is just a small sample of the various regulatory mandates that the city faces, and that DPW acts as the leading agency to be to keep us in compliance. Those regulatory mandates will require some type of plan to say, here's how we're going to do it. So the watershed implementation plans are a great example of that. When we want to look, though, at something along the lines of asset management, that'll be a combination of regulations and asset management. You'll find that in the Water and Wastewater Management Master Plan. And then we also have various stormwater pollution prevention plans and emergency response plans. You want plans, we've got them, there's lots of them. But at the end of the day, the plans end up resulting in capital projects and operational program enhancements, which means money. And that, from a local government standpoint, and for those of you who are in research, when we want to talk about actionable science, this is one of those endpoints. You can either look at policies or you can look at the projects. This is one of the endpoints of the decision making, is what are these capital projects and how can they be implemented? So the city, recognizing, and specifically the Department of Public Works, recognizing that all of these demands were coming out of the same customer's pocketbook. And previously, when we had looked at affordability, it was only looked in a silo. Like, what you needed to do for the consent decree was only looked at affordability for consent decree expenses. What was going to be needed, let me come back up here, what was going to be needed for the Safe Drinking Water Act regulations and the administrative order for our finished reservoirs, that was looked only related to affordability only on itself. So in working with EPA, Baltimore City submitted an integrated planning framework which looked at everything we needed to do for capital projects related to water as one large list. And it was it was more than just a simple cost benefit. We took the project list, we had assigned certain prioritization criteria, and going beyond the triple bottom line, we used something called a quadruple bottom line, which I'll talk about in a minute. We put a score based on those criteria for each of the projects. All those criteria also had a certain weight, and then the calculations happened. It was laid out along with a full financial analysis to then recognize what that revenue requirement would be from our ratepayers, and then we started to change things around. So if you were to try and complete everything in 5 years and it was going to cost $100 million off of your ratepayers, but that was too much because of where the affordability was at, we could demonstrate that we could have those same benefits met over 10 years for that same cost, for a very similar cost. And the really key point of integrated planning framework is that it's not a one and done. The first time we did the exercise was to demonstrate to EPA that we need some more time to achieve everything for our consent decree. But we continue to do this as part of our CIP process, and we have, excuse me, we have plans to start to integrate some of our solid waste projects as well as our operational enhancements. So looking at that criteria and what the quadruple bottom line looks like, environmental and social economic factors are in there, but we also look at project implementation. As much as possible, we try to look at criteria that could be applicable to all three of our systems and their related treatment plants, but recognizing that there are some things that we could never quite get there. I do want to also point out that when we look at drinking water, a lot of the criteria don't necessarily fall into environmental. They are much more of a social issue that we look at. Unfortunately, this is our modified criteria that we've just done. It's a little different than what we had submitted to EPA in 2013. But when we did the modification, you'll notice that flooding is not one of the ones that's on the list. It's somewhat there in the health and safety and improvement of quality of life criteria, but one of the things we wanted to look at in trying to evaluate any of these projects was to try and use objective methodologies in assigning the scores. And the reality is that for flooding, it was still a little intangible for us to say it had to be a specific criteria. So another thing that we are trying to look when we're looking at infrastructure improvements is to recognize that we're thinking outside the pipe. We're not just thinking about the storm sewer by itself, because there's a zone of influence that can happen. That picture that I had shown you earlier of the Monument Street collapse, where this large sinkhole, during that whole event, when the first collapse had happened, initially it was just over this pipe. But as more and more soil eroded, the water main became susceptible and it broke, which meant that you had a lot of water pressure coming out, not up, but out, which eventually eroded this area right here, which led to a sanitary sewer collapse. And that happened all within a very short amount of time. So when we're looking at our improvements, we are trying to look at all of the three pipes in any of the alignments. So if a water main is going to be replaced, and we are on track with replacing our water mains at a rate of 15 miles per year, we also want to see, is there any type of sanitary sewer improvement or storm sewer improvement that needs to be done at that same time. We're trying to do more and more to think also beyond water and see if Baltimore Gas and Electric may need to do those improvements. And part of that is also just to recognize that any of these improvements is interrupting the community at that time. So we want to go in there one time and only one time, if at all possible. The other part in recognizing this zone of influence is what could be possibly happening with these existing buildings. So, for example, if we are not addressed, so if in addressing this storm sewer, we decide to put a best management practice right here to try and reduce some of the flooding that may be coming down here, we have to be cognizant that it's not adding infiltration that could end up going back into this building. We're also trying to take a longer look, especially related to the regulations. A lot of the things that we've had to be doing for the consent decree has related to inflow and infiltration reduction on our sanitary sewer pipes. For sanitary sewer pipes, they are primarily gravity, so they're going to follow the lowest lay of the land, and so they are laid out in a lot of our stream beds and floodplains. So as we start to decrease the potential for any of that base flow of the stream to be going into the sanitary sewer, and we've seen a lot of evidence that our sanitary sewers are carrying that base flow. As we prevent that infiltration, there is a potential that the base flow within that stream could increase. And so when you're looking at what a flood model could look like, we want to have that being a consideration of the changes that may be happening with that base flow. On the flip side of it, with the installation of so many best management practices for the MS4 permit, not only within the city, but also the surrounding counties, that could play into a runoff reduction, because you're going to have greater infiltration into the groundwater, a runoff reduction, and that could have an impact on how much water is coming into our reservoirs up into the counties. So last, we got to look at external opportunities. For over 100 years, Baltimore City has been operating like a municipal water service operator. That is public use of it, and public stays public, private stays private. And we build up this wall a lot. But we recognize that for any type of sustainability or resiliency, we've got to bring that wall down. This has become even more noticeable in the last few years as we've looked at the MS4 permit and trying to restore or to treat runoff from impervious surface areas. The last permit that we had a requirement of treating runoff from 20% of the impervious surface area, which is roughly about 4,291 acres. When we looked at installing projects, we were only looking at public property. And this upside down inverted cone seemed to be the model we used, where you would have a lot of projects and locations identified. The amounts that were accessible started to become less. When you looked at the practicality of it, that was how much effort you were going to have to put in to put the practices in compared to what the treatment area may be. So we used a certain criteria of 0.2 acres per location. And then that left us with a very, very small fraction that could actually be built and worth building. And that fraction from the amount of locations that were identified to the ones that were built was roughly about 10%. So if you needed to, treat 10 acres, and you were looking at you would want to look at being able to build 50 locations, you would have to identify 500 locations, and that was just on public property. Public property is very limited for us. The city only owns about 5% of the properties outside of the right-of-way, and that accounts for only 6% of the impervious area. Most of the stuff is in the right-of-way, and as you recall from an earlier slide, that right-of-way is already being used for a lot of infrastructure and to get people moving. So the other part of the reality is when we look at private land, our downtown area is almost paved, curb to curb paved. There's not a lot of green space. If you recall from one of the first slides, I'll come up here. Where we do have green, it's along our major park areas. So there's large swaths of green, and that's where it's consolidated. So if you were to compare the city's impervious area to the total area, it's about 45%. But the reality is those pervious areas are very consolidated into those parks. So for us, to move forward, we do have development regulations that require more related to stormwater management as well as floodplain mitigation if they are within the floodplain. But in addition to that, we are looking at pay-for-performance models that we've seen in the surrounding counties where a contractor will do a design-build project and provide it for a certain cost, but access the private property that the city would otherwise not be able to easily do. And then the city, in the model that we're looking at, this is Anne Arundel County, the Anne Arundel County then would take over maintenance of that practice through an easement. Another thing that we are looking at is just how we can create incentives for more private green space installations, both on private land as well as in vacant lots. Not all vacant lots are publicly owned. They are private owned. So private nonprofit organizations tend to have a little bit more access to those types of lots than the city would. So this past spring, the City of Baltimore Department of Public Works, through a grant from the U.S. Forest Service, was able to create these grow center pop-ups. The idea behind the grow centers is green resources and outreach for water. It provides materials, building materials, education, and training to community members so that they are better able to install some of these green practices, including stormwater best management practices. So the photo up on the top left is a photo of our partners. The City of Baltimore is not doing it alone. DPW is not doing it alone. We had other city agencies as well as nonprofit environmental organizations working with us at these pop-ups. And the reason why we went with the pop-up is that we are learning that it is hard to build it and expect everyone to come to you. If you go into the communities, you're more likely to intersect with them. So we included workshops like how to create a rain barrel. We provided them with access to free mulch that would otherwise have gone to a landfill. This is the first pop-up that we did, was right across the street from a deconstruction project on a vacant lot. And deconstruction is a process where instead of demolition, where all the building materials are taken to a landfill, deconstruction is a little bit more careful and slow in the process so that they can recover as much of the materials as possible for both brick and wood and be able to reuse those. So one of our partners had used some of the brick from a deconstruction project, and that brick then could be used as edging for a community garden, or if it was broken even further, could be used as aggregate in the bottom of a rain garden. So this is one of the incentives that we are trying to look at above and beyond just trying to do grants, so that community members who typically do not feel any connection to water can start to do more things on their properties so that they can have improvements not only to the water but also to the air quality. And along the way, they get a little bit of education about certain things related to extreme weather events. So going forward, DPW is looking at what we can do to maintain and sustain our drinking water sources. A lot of this is related to our reservoir protection. Even though we have a lot of land and some great buffers, the forest condition around there has started to degrade. So we do recognize that some maintenance and some improvements into those forest buffers are going to be needed. The infrastructure improvements I had talked about before, those are going to be coupled with environmental restoration. And along the way, especially with the larger projects that we are working on, we are starting to look at what this will mean related to energy neutrality and zero waste, because we do think that the water to waste to energy nexus is the way that we are going to be sustainable and resilient for the future. So thank you very much for your time, and I'm open for any questions.
Wonderful. Thanks, Kim. I know from personal experience, I am a sucker for free mulch, so good work on that one.
Right.
if anyone has any questions, feel free to enter them into the chat queue, and I'll either try to turn on your mic or read the question directly to Kim. Just give it a second here and see if people can find the right buttons to push. We have a total of 37 people on the webinar, so we appreciate everyone's time this afternoon. It's a good turnout. So we do have a question wondering what a derecho is. That seems like a new term.
Yeah, and it was the only time I had heard that term. It's just a severe windstorm is the easiest way I can explain it. And it's rare for our area as well. And it happened for us in Maryland. We had it in between a hurricane and a tropical storm.
Okay, thank you. Well, you must, we got another question. Can you talk a bit about thoughts on achieving zero waste and energy neutrality?
Right. So we're starting that at our wastewater treatment plant. That's the first location, as much as possible, trying to take the byproducts and turn them into cogeneration, energy resources, looking at also solar energy. And our director, Rudy Chow, has challenged us that any other capital improvement at the facilities have to have either an energy reduction or even greater an energy neutrality element to that capital improvement. But it's tough. One of the major projects we have right now is a large pump project known as the Headworks Project, which is trying to resolve an issue that is over at the Back River Wastewater Treatment Plant. The planning and the pipe, the way the pipe comes in, it allows for the head to back up almost 10 miles before you get enough flow so that it goes to the wastewater treatment plant, which then results in a lot of sanitary sewer overflows, and it compromises the capacity. So we're having to install this large pump, and pumps take energy. So it's a lofty goal, but we do have within the Department of Public Works, we have an Office of Sustainable Energy. So we have energy subject matter experts that are working with our engineers on these designs to look at ways to reduce our energy, in addition to looking at the processes overall and seeing if any of those processes have the ability to create energy. And then on the zero waste, so on the zero waste side, we do have a Bureau of Solid Waste within the Department of Public Works. So again, we have solid waste experts as well. It's a benefit that I don't think all regional utilities have. So we're going to take that as a win for us, that the way that we are currently structured, that we have access to solid waste experts, and also the policies that are being looked at for the city to get us to either zero waste or minimal minimizing the waste. Right now, a lot of our solid waste is incinerated through Bresco, so it's a waste to energy. But we're also looking again at our processes and what possibly could be going out in the waste stream that could be otherwise reused. One of the good things that I was trying to point out for the Growth Center is that the materials that we are trying to make accessible would otherwise be going to the landfills. And so we are looking at repurposing as many materials as possible, and this goes in line with a program that came out of the Office of Sustainability known as Waste to Wealth.
Great, thank you. Paul is wondering if you could tell us a little bit more about trash as a pollutant for storm and wastewater and how serious of a problem that really is.
Sure. Let me get a sip of water real quick. So trash is a sort of weird pollutant, number one, because it's not easy to measure. It's not like it's soluble in water. And it's solely based on human behavior, especially in the city of Baltimore, where less than 50 years ago, or it was about 50 years ago, city policies were actually encouraging people to sweep, throw, or wash down any trash on the curb into the storm sewer. You know, at least you were having a clean street and out of sight, out of mind. So now we're having to correct behavior that is still only a couple generations old. It's very visible, but the regulatory performance measures don't align with the way that trash is. So when we're talking about trash, we're talking about floatable debris. And a lot of times that debris is plastic bottles and styrofoam, things that are very, very light. And so you don't need to, you need to have a large volume of it for it to have a heavy weight. That large volume is visible, and it's more of a nuisance for people. So it's out of all the pollutants that we have, it's the one that has the most public attention because it's the most visible, it's the most obvious. But it's just the hardest one to align with the way that the regulations are set up because it's based on weight. It's also one of the hardest ones for easily measuring, especially in the city, because we don't have a lot of good collection points. Did that answer your question?
Paul says, yes, it does.
Okay.
Basil, we're getting more questions. This is great. Basil is wondering if you could take a big gulp of water here, Kim.
All right.
In choosing whether to implement private-public partnerships for installing BMPs on private property, do you offer any financial incentives beyond taking over maintenance responsibilities for the installed BMPs? Are you looking at financial incentive models? If yes, what kind?
So the model, so the city has not entered into that public-private partnership. We're looking at that type of pay-for-performance model right now. What we do have, because we have the stormwater fee, the current incentive is a credit or a reduction on their fee if they have installed or maintained a best management practice on their property. But the reality is that stormwater management practices are not cheap to install, and they're not cheap to maintain. And when you run the numbers, we've run the numbers, Philadelphia's run their numbers, DC's run their numbers, you're looking at about anywhere from a 20 to a 40-year return on investment for it. That's why a lot of the times it's only the properties that have just recently been redeveloped or newly developed that had to install a stormwater best management practice as a part of the development requirement. Those are the only ones that are really asking for the credit. So that's why we realize that the cash incentive is a little bit tough. We do offer a grant program. The city does fund through the Chesapeake Bay Trust grants for nonprofit organizations, so that way they can use the money on either private land or public land. But at that time, it's just the city donating, giving the money and expecting some demonstration of a water quality improvement, but we're not taking over the maintenance of that. I'm trying to remember if those were all the questions that were asked.
Yeah, I think you touched on everything. Basil can pipe up if we missed anything, but I think you got it all. I don't see any more questions, so here, I'm going to unmute Basil real quick. Here we go. Basil, you want to give it a try?
Sure. My question was, beyond, I know that retrofit issues is where we're struggling the most, is how to encourage retrofits. I agree that it's very limited, the areas where it is possible to do it in green spaces, because mostly our land is already developed. So we are looking at maybe in areas where we lack green infrastructure to do retrofit model. And as she mentioned, it's very expensive, and if we don't offer a financial incentive, I doubt any homeowner or business owner would do it. So we are looking at what the possibilities are, what the funding mechanism would be, and if what other cities are doing in that realm, so that we can learn what the pitfalls are. And that's where my question was.
And so that was part of the impetus of doing things like the growth centers. We did the pop-ups just as a test run for things. But for the, even if we gave that financial, one of the things that we saw in the first year that we did grants was that there were still, the money still was not being used really efficiently or effectively. Designers were taking a bulk of the money because they were designing everything very specialized. There were certain things related to maintenance agreements and declaration of covenants. Just all of these little costs started to add up. Add to it that when you're in the city, and I think some of you are familiar with the terms food desert. So in urban areas, if you're already having problems with access to food, what do you think the access is to building materials and tools? They're not very much. So that's why we looked at it and said, just giving money is not going to be enough. And the growth center concept is trying to put private property owners, community owners, people who are not subject matter experts, but they have land, right? To give them access to materials. We also have access to tools and also knowledge, so that it makes that implementation a little bit easier to do. In addition to that, we've been looking at certain design and evaluation tools to provide online, as well as getting some standard details together, so that when we do get to a point where we want to look at either a pay for performance or something where we will have to give more of a cash incentive for private property, that money can stretch even further. But if you were to just look at a model and only look at the fiscal side of it and not look at the challenges of what the average private property owner who doesn't do this on a routine basis, what they're going to face, you're going to find that your money is not going to be used that effectively.
I agree. And that's why we're looking at, when we really develop some of our infrastructure, our road infrastructure, including them then, and then we don't have to hire a special consultant, and we can do it through, when
And Basil, where are you out of?
I'm in Colorado, Fort Collins.
Oh, okay, great. Yeah. One other thing that we've seen, though, this was out of a study out of Philadelphia by AKRS, is that the implementation of green infrastructure, the further you get it away from the right-of-way, the lower the costs are for both construction and maintenance.
Yeah, I agree. It's hard. Thank you.
Oh, thank you.
Okay, well, I haven't seen any more questions trickle in, so I think we've satisfied everybody. I appreciate your time today. Please tune in next week. We're going to be hearing from Greg Fisher here in Colorado from Denver Water and learning more about the challenges facing the Front Range. Kimberly, thank you for your time today. I'll be sure to send a link out as soon as I get this posted, and I hope you have a wonderful afternoon.
All right, thank you very much.
Take care now. Bye-bye.